Here we're going to look at question 71 from the IMAT 2011 paper. So in this question, we're given the following situation with a plank moving across this pivot point here. We're told that we have this weight of 200 newtons at one end of the plank, and then we have the other end of the plank, which is 0.5 meters from the center, which we've labeled P. And what the question asks us is what weight is needed at P for this plank to be at equilibrium. So if you'd like to have a go at answering this question yourself, then please just pause the video now. Otherwise, let's have a go at answering it together. Okay, so this is a question which is quite standard for a topic you might recognise, and that is going to be moments. So for the plank to be at equilibrium, then basically the moments at P have to be equal to the moments due to this 200 Newton force. So we have to have these equal moments. But for those of you who are less familiar, it might be useful to remind you what a moment actually is. And basically, the moment due to something is just going to be equal to the force multiplied by its distance. So, if we were to imagine that we had a force at P acting downwards, similarly to the 200 Newton force acting downwards, then the force is just going to be the weight of P multiplied by its distance from this pivot, 0.5 meters. So the moment is just going to be P multiplied by 0.5 meters. Then, if we go ahead and look at the moment of our 200 Newton force, then of course the force is going to be 200, and we can multiply it by the distance from the pivot, which is going to be 1.5 meters, since this plank is a total length of 2 meters, and 0.5 meters is this on this end. Therefore, to find P, all we have to do is just rearrange this equation, which we can do by dividing by 0.5, and then our 0.5 and 1.5 are just going to cancel out to give us 3, giving us that P is 600 newtons. So this is going to be our final answer and corresponds to A given in the question.